All right, next we're going to talk about templates, which are the C++, yeah, bless you, way of implementing generics, or basically parameterizing the type that you use inside of a function or a class. They're going to be, I guess, a source of a couple of issues. And because they're going to look straightforward, then all of a sudden they're going to have a dire conflict. Good morning. All right. So, bless you again. So let's go back here. Let's go ahead and create an 06 template class or directory so we can look at that class code. Oops. Now let's copy over my 06 operator overloading makefile right here. Source, main PDSR, obj, and source main.cpp. And I'm going to go ahead and set it all up. All right, now let's go ahead and think about what class we want to template on. All right, I don't know if a robot works. Start giving me other ideas. Let's see if we can come up with a good one. Food?
Yeah, like making a sandwich.
Making a sandwich, all right. What can we template with food?
A burger.
A burger? Burger class, okay, let me think. What can we do with a burger? Because what would the, no, because the burgers just contain ingredients. No.
You want like integers, you can do like number of pickles and like your stuff like that.
Number, yeah, but then we need the pickles to be also, we need to parameterize on something. I'm trying to think of what would work here. So nothing's coming up. So, we'll go with the classic array. All right, so up here we have the array, and we're going to do class, we'll call it array. All right, inside our lovely array, we want to give it a constant int size. And let's see, we probably want to be able to, we'll say for now it's an integer array, so int get int index. And then void set, and we'll just do int index int value. All right, I almost forgot my semicolon. So it's an array. Well, what's it going to hold? We'll go ahead and make it a integer pointer, the actual array. We'll call it the M array. And then int M size, because it needs to be able to hold a pointer to what the array is as well as the size. Hey, look, I think I'm doing your lab for you, but that's okay. All right. And let's go ahead and copy these two things down and then open up the source array.cpp. Doop, doop, doop. We'll include array.hpp. Great. And then we'll have the array, which is past the size. So we'll have m size equals size. When you get at the index, so we'll just return m array at the index. Hey, look, we're not doing any bounds checking. That's cute. And then down here we'll have m array sub index equal the value. Ooh, values. No, that's way too much. Do value. All right. So something else up here I forgot to do. What did I not do? So on the constructor, I set the size, but what did I forget to set? Yeah, the pointer. What's the pointer going to be? So the class is going to represent an array. We have a C array, irregular arrays, but we're going to implement it with a class. So if we're passing in the size, what should we do with our M array?
Pass.
Well, we can't pass the size to a pointer. Well, why did I make a pointer? Maybe that's the root question.
To point to.
To point to the array, right. So if we have the size and we have a pointer to point to the array, what do I need to do next?
Pointer to point to that pointer.
Point. You just did lab 5, didn't you?
Not yet.
Not yet? Oh, okay. All right, the class needs to hold the array as well as the size. So the pointer is going to point to the array. So if we're passed in the size, we need to create the array so the pointer can point to it so we can actually manipulate it. So we have MArray equals new int subsize. Or actually, I should use msize. I do recommend doing it this way. First thing, set your internal variable and then use your internal variable from then on out. That is simply a defensive coding mechanism so that if someone has to come in and start manipulating a lot of things right here, it will not, the chances of it messing up size later on is very low. All right, and did we create a main? Hey, we did. Great, let's make sure this all compiles first. Nope. MArray was not declared in the scope. MArray. Oh. Well, we should make it a part of the class, and that's what we need the array : for. Yeah, details. Hey, look, it ran. Or actually, it compiled. Now let's see if it runs. And it runs. Great. Well, we probably should create the array, but first we need to include it. How many elements should we have? 5. All right. Okay. Now let's do a .get on element number 2, and then let's print it out. What's the value going to be? Haha. Let's see if y'all been paying attention to all this. What value is this going to print out? Undefined, right. We don't know. It probably won't say undefined. It's going to give us a number, but it's not defined what that number is. So it did 0. A lot of times you'll get a 0 because usually memory is cleared, but that is not necessarily guaranteed. Okay, let's see. How are we doing? So the idea here, okay, that's nice. Oh, function templates. Okay. I started off with class templates. I should have done function templates, but let's do the class templates since we're already here. So if you wish to template a class, and let me go through the slides because I always forget the syntax. Perfect. Because, for example, in this situation, what is the type that array is holding? It's holding an array of integers. But if we want to parameterize what that is, similarly to your array list or your linked list inside of Java, we'd use a template. So over here we go template class T, and then we remove everything that was a T right here. So we put a T there, and we'll put another T right here, and we'll put another one right here. What this is saying is that when you create the class, you need to specify its type, and wherever that type is, or aka we're going to call it T, we'll put it down here and replace that T with the type. Size needs to be an integer because it's the size. Index is, of course, an integer as well, but what we're getting and setting is of type T. And look, it's a pointer down here to an array or to something of type T. All right, well, if we update the header file, we probably should update the CPP file. Let's see. It's going to be new T, and so the array is returning T, and down here is a value in order to set it. Okay. Now, is it going to compile? Let's find out. Invalid use a template array without an argument list. Ooh. Yep. So in order to do the templates, you now have to do this on every single function declaration. And I think you have to do this as well. So that's saying that this function, which is a member of that class, is template on class T, and the class is being sent the first T. The reason why you have to do it this way is with templates, you can template on more than one type. You could have the first type, the second type, a third type. This will make more sense when we go to hash maps. But for now, we're just going to have one type because this is already too confusing as it is, and it's about ready to get worse. Now let's try and compile it. Well, let me save it. I did not mean to do that. And compile it. All right, missing template argument before A or Y. Well, that's because when we declare it here, we need to say it's a template of something. What do we want to have it a template of? Or an array of, sorry, I should say.
Characters.
Characters, great. All right, now let's try and compile it. Undefined reference to array of the constructor and of get. Okay. What did undefined reference mean? Anyone remember? I know it's Monday. So if it has an undefined reference, that means it can't get to the code, which means that your code for the array is not included in the binary. But didn't we just compile that? So here's the problem with templates. Since templates, and this is really confusing, my apologies, but since templates are a compile time construct, they cannot be in a binary. They have to be in the source code. It's probably the simplest way to explain it. Templates have to exist in source code. They do not exist in a binary. So a template cannot exist in a .o file. It only exists in the .cpp because it's something the compiler understands and generates. It's not something that is generated from your binary code. That's taking a little liberty there, but hopefully that makes some sense. So the problem is, even though, let me go and close. If we go in OBJ, even though we have an array.o, this does not have the template inside of it. So the problem is, when we go to link it right here, because we're including all the OBJ stuff right here, it does not have access to any of these functions because they are gone. Now, there are different ways around this. I have yet to find a good one. They are all actually terrible. It's just how it is. But the simplest way I've learned is inside your header file to go ahead and include the CBP file at the end. Because then when you use it, it'll automatically generate it for you. Now if you type in make, or it'll blow up in your face. Previous read of, oh, okay. Oh, it's on infinite loop. Oh, can we stop it? All right. So, here we go. This is the next problem with templates. I told you it's only going to get worse today. What's happening here? Well, when we go to compile main, it's including array.hpp, right? Okay, great. Let's go look up source array.hpp. So we're in array.hpp, all right, nice. Oh, we're including array.cpp. Okay, let's go over to array.cpp. Oh wait, it includes array.hpp. All right, that's nice. So it jumps back to array.hpp. Oh, wait a minute. Oh no, we just created a circle. Okay.
That's the coding way to make it.
Yes. Uh-oh. So how do we fix this problem? All right, well, C++, you have something called directives. What you do is you can go up here and you go if not defined, I'll just call it array underscore HPP. We'll go ahead and define it, and then we'll put an indef right here. All right, this should fix it. This is a preprocessor directive. Now you have to learn about the preprocessor. Basically, when your code is before your code is compiled, there's a preprocessor that generates the code. And what it does is it uses these pound whatever to generate the code. The reason you need to understand that is if you actually go back to main, when the compiler compiles it, it's not actually compiling multiple files. It goes into all your header files and copy and pastes that code right there. So in other words, when I do include array.hpp, it just takes array.hpp, pastes it right there, and then continues on. So it's not actually including multiple files, it's creating one giant file. Now that preprocessor step, or that step before it compiles, you have another parameter that you can say that if array underscore HPP is not defined, then go ahead and jump in here and include all this code. Well, what's the first thing I do here? I define it so that next time someone includes array.hpp and they go up here, they will see, oh, it is defined, and they jump to after the if. So keep in mind that the preprocessor has a separate, it's kind of like a separate little programming language, although it's not a complete one. But you can do basic if statements. So this, I'll say, coding pattern ensures that the header file is only included once, is the objective. All right, everyone thoroughly confused now? Make a little sense though? The point of this is so the header file is only included once. Let's try that again. Oh, look, I think it might actually work. Oh, good. All right. Well, that was fun. Please tell me I recorded all that. Oh, good. All right. So you can watch that explanation again. The key takeaway, or a couple of key takeaways, is this whole pound if indif right here and not defined, or if not defined, define is just a pattern to make sure that your header file is only included once, no matter how many times someone tries to include it. And let's see. And inside of templates, I'm going to make a comment right here. For templates, we include the .cpp. All right. If you aren't using templates, never include the CPP file in your header file. Bad things are going to happen. All right. You're going to get a lot of double definitions, so forth and so on, if you choose to do that. So please never do that. Okay. So, where were we? Array of characters, we get them at 2. All right. Let's actually set it so it makes some sense. We'll set it to the good old big O. That way if we compile and run it, now we have an O. And hey, look, we can create another one. We'll call it a floats. We'll call it the F array, almost like fairy. And we'll set element 1 to 3.14159. F array get at 1. All right, and now that's set up, you can actually have your two classes that are templated on that array that's templated on a type. So you can create an array class based on two different types. Which types can we put in there? We can put all your primitives, character, float, integer. You may also put any class you want inside of the template list as well. So if you wanted a class of students or of robots, we could do that as well, or array of robots. All right, so I jumped to the class template exercise, which was definitely getting ahead of myself. Let me go ahead and do a simple template for a regular class. So if we do template class T, we'll call it the good old add function. No, let's not implement it right here. Turn A plus B. Compiles, great. So now, if I wanted to, I could do add of 1 plus, or 1 comma 2, which will add 2 of them as integers. I could also do 1.5 and 2.6, which will add them as floats. All right. Hopefully the function version is now a lot simpler than the code version or the class version. But it's the same idea. I could, you can do primitives. Can we put a class to this one? Like, could I create a robot class and do plus, or call it to add? And this is where I think we need to think about it for a moment. If I create a robot class, could I, or am I allowed to, first off, am I allowed to send it to the add function? I just want to sit down.
Yes.
Yes, great. Is it going, that's correct. Is it going to compile and run?
I think so.
Think so. Okay. Well, here's the question. Does a robot class implement the plus?
Yeah.
Currently, yes. So if you're, so for the add function to work, your object that you pass to it, or the class, has to overload the plus operator. Otherwise, this function won't work. Y'all see that? Now, if I created a multiply one, therefore, if I created a multiply one, this is the next question, where I use multiplication instead of addition, would that work with our robot class as it stands? No. But we could make it work by overloading the multiplication operation inside of robot. Now, I don't know exactly what that means to multiply two robots, but I mean, C++ would allow us to do it. I don't know what good that would be, but
If you passed like integers to the add function,
right up here.
yeah, would you still have to like you did there? So you don't need to overload the plus operator?
Well, because the plus operator already exists for two integers, right?
Okay.
Yeah, that one already exists. The thing to understand is your operators are just functions.
Gotcha.
Just think of it that way. They're
So
all
you could do it
functions.
with strings too, right? 'Cause you
Yeah, if the string object, you could overload it. Yeah, yeah, because that class overloads the plus as concatenation.
Okay.
Good questions, or good comments. Okay, how are we doing? Because this is all the new stuff today.
I'm so just out of it, to be honest.
Oh man. All right,
Nothing to do with the class. I'm just out of it.
just out of it. Okay.
Yeah.
Hmm.
I think I'm just having one of those days.
Yeah, this week has been rough for me.
Yeah, it's been a weird week. Yeah.
All right, let's go pause